Welcome to The Explainer. Today, we're tackling one of the biggest, most mind-bending questions humanity has ever asked. Where is everybody? We're going to dive into the incredible challenges, the cosmic puzzles, and some wild possibilities in our search for, well, anyone else out there.
All right, so let's jump right in. The most obvious way to find out if we're alone is to just go look, right? To actually get there.
And, well, that's where we immediately hit a wall of just sheer, unimaginable distance. This first part is all about the staggering physical barriers that separate us from even our closest stellar neighbors. So get this, 4.2 light years. That's the trip to Proxima Centauri, the next star over. In cosmic terms, that's our next-door neighbor. But for us, with our fastest spacecraft, that journey would take tens of thousands of years. This chart really puts it into perspective. To make an interstellar trip happen in a human lifetime, we need to hit at least 10% of the speed of light. Our fastest probe ever, the Parker Solar Probe, only reaches about 0.064% of light speed. We're not even in the ballpark. We're not even playing the same sport yet. And here's why we're so slow, at least with the rockets we have now. It's called the rocket equation paradox, and it's a real killer. To go faster, you need more fuel. But more fuel makes the ship heavier, and a heavier ship needs, you guessed it, even more fuel just to get going. It's this vicious cycle that basically makes the whole idea impossible with conventional tech. So, to get around this, scientists are looking at some seriously futuristic, sci-fi level stuff. We're talking about things like harnessing nuclear fusion, the power of a tiny star in your engine, or using these gigantic sails pushed by sunlight. But the real holy grail? That's antimatter propulsion. In theory, that could get us up to 90% the speed of light. Wild. And even if we invented that perfect engine tomorrow, the problems are just getting started. I mean, how do you even navigate that far out? Maybe using pulsars as cosmic lighthouses? How do you talk to Earth when a message takes years? And then there's the biggest stuff. How do you keep people alive for centuries? What about radiation? And what are the ethics of launching a generational ship where the great-great-grandchildren of the crew are the ones who might, maybe, arrive? Okay, let's switch gears for a second. Because even if we could travel the stars, we're still completely stumped by some fundamental paradoxes about our own universe. Puzzles that make it seem like reality itself is breaking its own rules. Okay, check out this classic thought experiment. It's deceptively simple. If the universe is infinite, and it's been around forever, and it's full of stars, then no matter where you look in the sky, your line of sight should eventually hit a star, right? So the entire night sky should be just blindingly bright. It sounds like such a simple, almost kid-like question, doesn't it? But it's profound. The fact that the night sky is dark tells us that at least one of our basic assumptions about the universe, that it's infinite, eternal, and unchanging, has to be dead wrong. And the solutions we've found have completely revolutionized how we see everything. First, we know the universe had a beginning, the Big Bang, about 13.8 billion years ago. So the light from the farthest stars just hasn't had time to get here yet. And on top of that, the universe is expanding, which actually stretches out the light from those distant galaxies until we can't even see. But Olber's paradox? That's just the tip of the iceberg. Cosmologists are wrestling with these other massive mysteries, like why the universe is so perfectly balanced, or what really happens to stuff that falls into a black hole. Each one of these puzzles is a giant hint that our instruction manual for the cosmos is still missing a few chapters. So, we've established the universe is huge, ancient, and super weird, which brings us right back to our big question, but now it feels even heavier. If life has had billions of years and billions of planets to get started, then where is everybody? This is the absolute core of the problem. It's called the Fermi paradox, named after the physicist Enrico Fermi, who supposedly just blurted it out at lunch one day. The numbers say the galaxy should be teeming with civilizations, some of them way, way older than us. But when we look and when we listen, we get nothing. Just silence. Now, one of the most chilling possible answers to this paradox doesn't come from a science textbook. It comes from a science fiction novel. It's called the dark forest hypothesis, and it suggests that the silence out there isn't an accident. It's a choice. It's a survival strategy. The logic is terrifyingly simple. In a universe where you can't be 100% sure of another civilization's intentions and you have no idea how fast their technology might advance, the only truly safe move is to assume the absolute worst. So the first one to shout hello becomes the first target. In this game, broadcasting your existence isn't a greeting, it's a death sentence. This idea completely reframes the whole question. The Great Silence isn't an empty concert hall, it's a full one, where every single person is holding their breath, terrified to make a sound. It's not an absence of life, but a sign of intelligent, cautious life that knows the number one rule: stay hidden. But hold on, because there's one last powerful twist we have to consider. What if this whole time we've been asking the right question, but looking for completely the wrong thing? Okay, so all life on Earth, everything we've ever seen, is carbon-based. Carbon is amazing at what it does. But right below carbon on the periodic table is silicon, and it has some similar properties. But there's a huge difference. When we breathe, we exhale carbon dioxide, a gas. A silicon-based creature would exhale silicon dioxide, which is essentially sand. Imagine that. And that right there is why we might have missed it entirely. Life based on silicon wouldn't want a nice, watery world like Earth. It would probably thrive in places that are total hellscapes to us. No water, crazy temperatures, maybe using something like liquid methane to live. Places we write off as uninhabitable, like Venus or the moons of Saturn. And that's the real kicker here. Our entire search for alien life, our whole definition of a habitable planet, has been completely biased by what we are. We've been looking for Earth-like life on Earth-like planets. We haven't been searching the universe. We've been searching for a mirror. So that leaves us with this final mind-bending thought. What if the answer to where is everybody isn't that they're hiding or that they don't exist? What if they're everywhere? And what if the great, eerie silence we hear isn't an absence of voices at all, but just the limit of our own ability to listen?